All right, welcome to the 3D figures and cross sections instruction practice that you guys need to get through. Here I'm providing the slides that have fill in the blanks, a little instruction on how to make sure you guys can get through those. You should have already watched the lesson part, the instruction part of each of these videos. Obviously that will help you get through these if you get stuck on one. Question on slide 2 says, we already clicked through one of these. It says the base, top and bottom of the three-dimensional figure are two congruent triangles. We see these two parallel pieces are triangles right here. Those are considered the bases. And then all of the other surfaces are called lateral surfaces. Each one of these surfaces on the sides, not the bases, are going to be parallelograms. If it's a right triangular prism, then they would be rectangles. Otherwise, they could be some sort of parallelogram. For the next one on slide 4, I just wanted to point out the individual pieces it's talking about. Given the three-dimensional figure, I can see there are two of the exact same shapes that are opposite of each other on the sides. These two triangles, there's two bases, they're opposite of each other, they're both triangles. That makes this a triangular prism because all of the other surfaces in between there are all parallelograms or rectangles. So that's a rectangle, and this side over here is also a rectangle. So the two bases are what make it a prism. Because the bases are a triangle, that makes it a triangular prism, and all of the lateral surfaces are rectangles. One of the edges, edge JM intersects LM, so I can see here if I erase some of these other pieces that I already drew on there. Where does JM intersect LM? If I trace on there JM and LM, looks like they intersect at point M, so definitely is point M on there. Question on side 6 says determine which statements are true regarding this solid. Check all that apply. The three-dimensional solid is a hexagonal pyramid. Well, I can see that there is a hexagon on the bottom. It's got 6 sides. And because there's only one base and the other side, there's not a base, we know it's not a prism. Because all of the edges meet at this vertice at this one point, we do call this a hexagonal pyramid. So that is true. So one base, all of the lateral surfaces are triangles, that is a pyramid. The next one, the three-dimensional solid is a hexagonal prism. Well, it's only got one base, so it's not a prism, so I know it's not going to be that one. The next one, solid can be created by stacking the same size hexagons. No, each one of these hexagons should be getting smaller and smaller, a similar version, so it's not going to be that one. If you stack the same size hexagons, you get a prism. The next one, the solid can be created by stacking dilated. Yes, each one of these is getting smaller, so that's what I just mentioned on the last one. Should be true for that one as well. And last one, point D is the apex or vertex of the pyramid. That is correct. So the 3 that we should have come up with are these 3. All right, the question for slide 8 is asking about a cross section. So in this one, we have to pay attention to what type of cross section we're doing. It says, what is the shape of a horizontal cross section of a given pyramid, given prism? So horizontal, we know, goes left and right. Remember, vertical goes up and down. So if I do a cross section horizontally, like this way, what kind of shape are you going to get? You should get this kind of shape that looks exactly like the bases. So you should get a pentagon shaped cross section, the same as the bases. Now, if you did a vertical cross section, you'd end up getting some sort of rectangle depending on where you did it at. So if I was to do some sort of like vertical cross section, it may end up looking something like this and end up being a rectangle on there. In any case, it did want a horizontal one, and we came up with a pentagon. For the question on slide number 11, says it's asking about rotations. What solid will be produced if the rectangle ABCD is rotated around line M? Assume line bisects on both sides. So it's cutting this right down the middle of there. Okay. What will the dimensions of the three-dimensional solid? So if I rotate it, pretend like it's a pencil with a little flag on it, and you're going to rotate this around, and it looks like that point there, I could rotate around. This one here, spin it around. Looks like we end up getting a cylinder. We get this shape right here. All right, and I know that the height of that is going to be 5 inches, and the radius is 6. So it should be a cylinder with a radius of 6. You got to be careful that you know the radius is 6 and not 12. The diameter is 12, but the radius is 6. You can visually think of it as being stuck to a pencil when you rotate it around like a little flag. If you did it really fast, what it would look like. Another interesting question about rotations. Which two-dimensional figure will create a cone with a radius of 3.5 and a height of 7? So if I rotate this one around, we get kind of two cones on top of each other. That's not going to create, oops, wrong shape that we get there. Oops, I rotated the wrong part of that one. Let me fix it here. So if I rotate this part around, and I rotate this part around, we actually get this inverted cone shape right here. We actually kind of get like, you can see inside of this cone right here. It looks like a cylinder with a cone cut out of it is what it ends up looking like. All right, so that's not what we're looking for. We're looking for a cone. That we get some sort of weird cylinder with that one. Not going to help us. The next one, if I rotate this around, I can rotate this point here. I do get a cone shape, so I get this cone shape right here. But this one has a radius of 7 that I can tell. This equals the radius of that cone, and the height of the cone. Because this is the base, the height has to be perpendicular. The height of the cone is 3.5. So that's not what we're looking for. We're looking for a radius. So notice this one here, if I rotate it around, this is going to rotate all the way around here. And then I do get this cone that does have a radius of 3.5. And does have a height of 7 there as well. So that piece there is 7. That is the one we're looking for, so it should be this third one. Last one we have here is asking about a cross section. Which of these could have a vertical cross section? That is a circle. So we need to be thinking vertical cross section. So if I was to cut this one right here with the vertical cross section, whoops. What do I get? Looks like we get some sort of rectangular shape right there. You'd literally get, this cross section right here, which looks like a rectangle. Same thing here, you'd get some sort of rectangle if you did this cross section. You're going to get an ugly rectangle in there as well. This one you're actually going to get either a hyperbola or a triangle, depending on where you cut it. So this one right here, if I was to cut with a cross section, you're actually going to cut this shape right here. And if you look at it from the side view, it actually makes a parabola or hyperbola shape that you may have learned about in Algebra 1. So not quite exactly the shape we're looking for here, not a circle. If you did a horizontal cross section, you would get a circle, but it is asking for a vertical one. So this one here, looks like the obvious choice. I should get a circle. You're just making a cylinder that's a little bit shorter if you do that cross section on there. And it does have a radius of 7 still, because that cross section is going to be the exact same as the base on there. All right, hope that helped out. Be posting more videos soon. Be sure to check with your teachers if you have questions. Make sure you're keeping up with your schedule on Edgenuity.